Hey folks, I wanted to walk you through an update for Sutro Yaro and to just be very clear what it really is in the simplest way possible is that the Sutro Yaro is a structured workspace that allows coding agents to become a category of research agents, or rather a category of group of research agents. So there is nothing fancy going on other than being able to structure it in a way that the coding agent can navigate it, and then it would be able to perform these tasks that we have. So roughly that's what the diagram is over here that you're going to see. Okay, so what we're going to do today is that we're going to utilize two different set of coding agents, one of them being Claude Code, and the other one is the Gemini CLI. And then both we're going to go with the largest, or rather the best performing model possible within the coding agent to help us perform a task. To sort of highlight what we are going to demo, we're going to try to have our coding agent perform a task and try to see how much work it takes. What are some of the unexpected things? Was it easy? And what are the main takeaways? So I initially had a task in mind. However, the agent have already performed that and already has done a write-up. So alternatively, we're going to try using this egalitarian gradient descent approach to try to drop EGD to potentially perform the sparse parity and the sparse sum below 10 milliseconds. There is a lot more context to this. If you go back, the agent have done a whole write-up on the to-do, and then there's a whole section of discoveries and context to this problem. And whenever these results get published, you can actually observe them on this public website called changelog. So that's a lot of talking. I'm just gonna right now jump in and then try to perform this sort of task. So this dangerously skip permission and team mode. Dangerously skip permission might be a little bit misleading because it does not really dangerously skip permission. It's a lot more like allowing the agent to do a bit more experimentation in this scenario. Okay, so there are two things we can do. One of them is that I oftentimes actually just pop in here because this is connected to the Telegram and the Google Doc. I can ask a question, hey, what are the most recent updates that the group is talking about, specifically in the Sparse Parity Challenge channel and the chat yet? So, so this is sort of my way of trying to just see what's going on. Spark. Okay, I guess there's going to be text-to-speech errors because that's one of the unexpected errors that we are going to have. Okay, so while that's happening, I'm going to also launch the Gemini CLI over this side. So the -- YOLO is the equivalent of dangerously skip permission. Just to kind of give you a bit of explanation of what's going on. So okay, so this guy is kind of getting confused over here. So I might go ahead and ask, okay, I guess it's figuring it out itself. So the skip permission part is really not a big issue in this example that we're in, and the main reason that is because we're not really mutating production data, and because we are versioning the data, even if it breaks things, we can bring it back. Okay, so I'm going to ask the agent to perform this task. So we're asking the Gemini CLI to perform this task, which is a different repo, just to keep in mind. It's a clone of that repo, but this is the original version. Okay, so this gave us a heads up. It's talking about me, saying that I'm going to do this video that I'm doing right now. Okay, so I'm actually going to now just perform the same task over here. So the task is implement and test the egalitarian gradient descent on the sparse parity, see if it breaks, 10 milliseconds. Okay, so what I want you to pay attention to is that two things. My coding agent specifically for Claude Code, as you can see, it's actually really annoying to do this with Gemini. I make it verbose, so it actually tells me everything it is doing. So this is actually really important to understand how this coding agent would function as a research agent. So that's like, I would say, the first step. The second step is that these sort of skill sets are actually things that you end up creating as you go along. in order to reduce the steps that the agent takes in order to perform that. Okay, so the agent came back to me. It says, I have that. It says, what framing do you want? Okay, so it's giving us options. The project already has EGD listed as to do. The strict reliability, logging elimination. I'm leaning towards 2, first proof. Sounds good. Let's try that out. In fact, let's try both of them. And then let's compare results. And then after that, let's try the sparse sum example to be compared. But ideally, we're going to utilize the GPU because we want to measure the efficiency, as you may know. And keep in mind that you do have access to Modo Labs if you want to deploy it. The most important part is to keep track of the results because we need to do a write-up. So that is basic. These things that I'm saying are not just out of blue. Okay, actually, let's wait, hold on. So look, what is this saying? The user wants, so this is like really important. This is what you want the coding agent to do. This is what really makes it a research agent, that it takes this complicated, fluffy language that I'm using, and it tries to break it down into a set of task lists, and it tries to turn into like some order of operation. And so this is going to run the result. I'm going to probably pause it for the sake of time and then try to see what the results will be while it's going to do the implementation. Also, all while that's happening, unfortunately, this is how long it takes for Gemini CLI to perform that. This is not a good demo. I should have tried Codex. I don't know what this is even doing, configuring, okay, this is bad. All right, so this is good over here. This is the thinking trace, says approach A is recommended. Look at that, it already has even told me, let's go with A. All right, I'm gonna pause this time and then I will come back when the results are out. Hey folks, I'm back. So the coding agent ended up finishing the experiment of applying the egalitarian SVD variant, or it's actually EGD, to the sparse parity and the sum, both of them. The agent itself took about 9 minutes, not only to run the experiments, but also to do verification, reasoning, do the deployment on Modo Labs, to do the GPU, do a whole write-up, and also, so altogether, experiment and writing solution and adding a new problem set took about 9 minutes. That is for Claude code. Unfortunately, it did not end up working out too well for Gemini CLI. It took not only longer, but it went into some dark hole. But it ended up switching into anti-gravity, and so that we also have some results that we can look at for anti-gravity. I will explain this a bit more later. I think right now I want to focus on answering the questions, the main 3 things, which were how long it took, where were like some of the unexpected things, and what we learned, and what is the outcome. So I'll put this on the back burner. But for now, the main things that we learned is that, first of all, the effort only took about putting in really a couple of prompts. I guess you could call them prompts, but it was just me directing the coding agent to perform the task. And then eventually I ended up here after 9 minutes, which basically I said, do you have a write-up? And what are the findings? And it goes like, yes, I have a write-up. This is the document. And then it eventually, and then I said, commit, deploy, and help me write up a message for the Telegram for the team to share with you all. And so overall, if you were to measure the time, it did take an hour, but it was not really an hour. It took about 12 minutes and a couple of back and forth to do this. I ended up getting distracted, leaving my computer and coming back. So it kind of teaches you that there needs to be a better infrastructure to have actually the coding agent who communicate with you back and forth, have a proper notification system, so when it completes, for the agent to follow up with you. But yeah, so I think like that's like one answer, how long it took and what are like some of the step process looks like. In terms of the finding, I guess there are a couple of interesting things here to look at, but I think like the big finding here is that it did end up doing slower but higher accuracy. The sub 10 millisecond was not achievable with the EGD. And the EGD did solve the sparse sum where the standard SGD diverged. So that's pretty cool. And then, yeah, so I think like that's, and I'll share some of my notes. But yeah, that's sort of what it looks like. If you were to get cloned as repo, you could ask the agent to first get you up to speed of what's going on, but then also try to add your own experiments and then either do a branch or you can continue on your own branch and or you either try to contribute back. So either way, I hope this is useful. I will try to do a more compact version next time.